Okay, so this lesson is about the counting principles. Counting principles also, when we talk about probability, it's not technically probability, it's underneath that big, I don't know what you want to call that, like surrounding thing that's called, but these are actually, we're not actually talking about what's the probability that you would flip a coin or roll a die or draw a card. This is figuring out possible number of ways that things can happen. Okay, so first thing is the fundamental counting principle. This is, I think the example I used in Algebra 2 is when we're talking about making a Subway sandwich, where you have this many kinds of bread to choose from, this many kinds of meat, and then cheese and veggies, etc., and you multiply all those options together. That's the fundamental counting principle. So, I forget what they're called, but like the Coca-Cola freestyle machines, they always say there's so many combinations of drinks you can make. Well, yeah, there are, because what they've done is they've taken every possibility and then they've multiplied those together. Okay, and then most of the stuff that we'll talk about today will be counting. You're just going to be counting things, figuring out how many possibilities, and then you're going to multiply those all together. Then we'll talk a little bit about permutations and distinguishable permutations. Okay, permutation, that is when order matters. So when you're talking about running a race, that would be a permutation. Okay, if I talk about how things are going to be seated or how we're going to figure things out, if the order matters, that's a permutation. When you're using your calculator, or how you're going to write it, is with the NPR. Okay, NPR is in the same area that we found NCR. It's in the probability. Okay, but the formula, if you want to use the formula instead of using the button, is n factorial over r factorial. Same thing, biggest number always comes first. You're always picking, that's why I always talk about picking versus choosing. You're picking from this many people how many you want. Okay, then a distinguishable permutation. It will actually use the word distinguishable permutation. That's how you figure out like how many words you can make out of this word. Okay, how many ways, different ways could you rearrange these letters or rearrange these numbers? So what you do is you count how many things there are. That would be a factorial on top. And then you divide by each kind that they have. So you take the first one. If there's two of those, that'd be 2 factorial. Times, and then you do the second one, however many there are, all the way up until you get to the last one, which we'll just call NK. And you multiply those all together on the bottom. Now make sure when you're doing this, pay attention to your order of operations. You've got to multiply all those together first before you divide. Okay, then a combination. A combination is when order doesn't matter. This is when we use NCR. Order doesn't matter. If I say get in a group of 4 people, I don't care who you pick first, second, third, fourth, doesn't matter. I just need you to get in a group of 4 people. Okay, it's the same formula we talked about yesterday, which is n factorial over r factorial times n minus r factorial. Same thing. I'm saying most of you guys will probably use the buttons. Remember, if you're going to just find the factorials, it's in the same place you're going to find these. It's in the PRB. Okay, these examples have a lot of words. I'm going to talk through them probably pretty quickly as I read the problem. If you're wanting to write them down and take notes, probably going to have to pause the video. Okay, we're going to start about this is kind of talking about sample space a little bit, but we're not actually finding probabilities. We're just finding the number of ways things could work. So it says determine the number of ways a computer can randomly generate one or more of such integers from 1 through 12. So the first thing says an odd integer. Well, you're counting how many odd integers are there from 1 to 12. Well, we have 1, 3, 5, 7, 9, 11. So that'd be 6, so my answer is 6. There's no probability, there's no like figuring it out, you're literally just counting. Okay, next one says an integer divisible by 4. Okay, well, if I go, the first one will be 4, then the next one will be 8, and then it'll be 12. So I have 3 numbers that are divisible by 4. Okay, distinct. Distinct means different. So if I say 2 plus 3, that's different than 3 and 2. 3 plus 2. Okay, only when you see the word distinct. So if I'm trying to find how many ways the sum is 9, 1 and 8 is different than 8 and 1. 2 and 7 is different than 7 and 2. So I want to figure out how many ways can I take 2 numbers and add them to get 9. Now remember, your numbers only go from 1 to 12. Okay, so, and I'm going to just write them out. So then I have 3 and 6, 6 and 3. So I did 1 and 8, 2 and 7, 3 and 6. Then I'll do 4 and 5, 5 and 4. I've already done 6s, so I'm done. So how many different ways are there? 1, 2, 3, 4, 5, 6, 7, 8. So my answer would be 8. Okay, so the word distinct means that it matters on the order. Okay, so now everything else will be story problems. Okay, customer can choose one of 3 amplifiers, one of 2 CD players, and one of 5 speaker models. Determine the possible number of system configurations. Okay, this is a counting problem. So I'm going to pick one of 3 amplifiers, one of 2 CD players, and one of 5 speakers. So how many possibilities do I have? Well, I'm going to pick one from 3 amplifiers. I'm going to pick one from 2 CD players and one from 5 speaker models. You multiply those numbers all together. This is the fundamental counting principle. To figure out how many possibilities, you multiply. So then my answer would be there's 30 different ways, that or configurations, whatever label you want to use is fine. Okay, number 5, in how many ways can a 6-question true-false answer be answered? Sorry. And how many ways can a 6-question true-false exam be answered? Assume no questions are omitted. Omitted means you can't leave anything blank. So, okay, nothing's omitted. We're answering every single question. So I have 6 questions, and I have 2 options for each question. So for the first question, I have 2 options. For the second question, I have 2 options. For the third, I have 2 options. 4th, 5th, 6th. There's 6 questions. You multiply those all together, and that's how many different possibilities that you could have to answer this question. So 2 times 2 times 2 times 2 times 2 times 2. So there's 64 different ways you could answer a 6-question true or false exam. Okay, in the state of Pennsylvania, each state or license plate consists of 3 letters followed by a 4-digit number. And how many different license plates can be formed? Okay, so the first thing has 3 letters, then we have a 4-digit number. Well, how many letters in the alphabet? So there's 26, and it doesn't say that once you've used it, you can't use it again. So we have 26 options for my first 3 letters. And then a 4-digit number. Well, if you think of all your single digits, you have 1 through 9 plus you have 0. So there's 10 options for each of those 4 digits. Okay, multiply all together. This is how many possible license plates you could have, and it's a really big number. Okay, so there's 175,760,000 different license plates that Pennsylvania can use if they use the same method for every standard license plate. Okay, if you notice, we still haven't gotten to anything where we're using the PM or the NPR or the NCR. We haven't even talked about permutations or combinations. Everything is still counting. If you can count, it's a lot easier. Okay? And that's what a lot of this will be anyways. It's just the counting to figure out your different ways. Okay? Do a couple more. Okay, number 7. 4 couples have reserved seats in a row for a concert. And how many ways can they be seated if A, there are no seating restrictions, and then B, the 2 members of each couple sit together? Okay, 4 couples. That means there's 8 people. Okay, no seating restrictions. So if there's no seating restrictions, and I go and I have a row of 8 seats, how many people can sit in the first seat? Well, all 8 can pick from that first seat. Once that seat's gone, that person sat down, there are 7 people left. That means there's 7 people that can sit in the second seat. Okay, then in the third seat, it goes on down all the way until you get to the last seat. Okay, and this should look familiar when you see it multiplied, every number down to 1. That's a factorial. Okay, so if you realize it's a factorial right away, and then it might be a little easier to solve, this would be 40,320 ways. Okay, B, if the 2 members of each couple want to sit together. Okay, well if that happens, there's still 8 people that can pick the first seat. Okay, well if I sit down, that means whoever my partner is, my couple, okay, which would be Zach for me, would have to sit next to me. That means there's only 1 person that can sit in that seat. Okay, when I get to the third seat, everyone can still choose. No one cares who sits by Zach. So that means that there would be 6 people to choose from that seat. Whoever's sitting beside me, then whoever's sitting beside Zach, their partner has to sit beside them. So there's only 1 option for that seat. Okay, then there's 4 people left, so there's 4 options. Then their partner has to sit beside them. They have 2 options, and then the partner has to sit beside them. Okay, so there's only 1 option. That is going to be a 1 that you're going to multiply there. So this would be 384 different ways. Okay, this is also, okay, when you're thinking of things like this is not taking into account who you want to sit by, whether boys and girls will sit together. This is thinking of if nothing matters, how many different possibilities there are. Okay? Alright, so now we're going to get on to number 8. And number 8 uses the words distinguishable permutations. Unless you see those 2 words together, it's not a distinguishable permutation. Okay? Okay, so it says find the number of distinguishable permutations of the group of letters. So the first thing you do is you count how many letters, or if you're doing a problem that has numbers, you count how many there are. So 1, 2, 3, 4, 5, 6, 7. That would be 7 factorial on top. Okay, then on bottom, you do how many times they repeat. So like if I go look at my A's, I have 2 A's, so this would be 2 factorial. I have 1 G, so that's 1 factorial. Well, 1 factorial is 1, so you don't have to worry about that. Then I would have 3 E's, so this would be times 3 factorial. And then 1 M, so 1 factorial is 1. Okay, so I figure out what 7 factorial is. I figure out what 2 factorial times 3 factorial is. And that's how many distinguishable permutations there are. Make sure this gets multiplied together, then that gets divided by that. So be careful on your order of operations. So this would be 420. different ways you can arrange those letters. Now, are all the ways you're going to arrange the letters going to make words? No, it didn't ask that. It asked for how many different distinguishable permutations that you have. Okay, when you get to this problem on your homework, after that is when you're going to have to pick whether or not it's a permutation or a combination. So I'm going to give you two examples. One's going to be a permutation and one will be a combination. Permutation is when order matters. Combination is when order doesn't matter. Okay, so number 9. A baseball coach is creating a 9-player batting order by selecting from a team of 15 players. How many different batting orders are possible? Okay, batting order. It matters where you bat, because if you bat first in the lineup, you can't bat anywhere else in the lineup. So this would be a permutation. Okay, there's 9 players, and there's a total of 15. How do I know which one comes first? The biggest number always comes first. So permutation, so this would be 15 P, or we're doing a 9 batter lineup. So I would do 15, then I would do my NPR, then I would hit 9, and that's going to be a big number. So 1, 8, 1, 6, 2, 1. Okay, so there's 1,816,214,400 different ways that this coach can make a lineup. Okay, also realize this isn't really realistic. When you're thinking about Coach Stanley, he might have 15 players on his team, but if they're a really bad batter, he's not going to have them batting 4th or 5th in the lineup. Okay, they're strategically, how do we pick the first batter in the lineup? Okay, somebody that has high batting percent or on-base percentage, and somebody that's usually quick is usually who you pick for your first batter. This is just determining how many different possibilities that there are. Okay, the last one. From a group of 40 people, a jury of 12 people is to be selected. And how many ways can the jury be selected? So I have 40 people, 12 people on the jury. Doesn't matter who gets picked first for the jury, so this would be a combination. So this would be 40 NCR 12. Okay, this is going to be another big number. This is why I would rather use the button on the calculator than have to figure out all the factorials separately. Okay, so there's 5,586,853,480 different ways that you could select a jury. Okay, not necessarily realistic. People get kicked out of the jury all the time because of different beliefs, or they've already made up their jury so they don't have to keep interviewing people. This is just possibilities, as if you'd have 40 people come and they need to select 12. These are different combinations that are possible. Okay, this will get you all the way through lesson 9-6, which is over the counting principle.